Good morning, everybody. Thank you for this opportunity. I am Gianni Jacucci from the University of Trento in Italy, and I have a talk which is entitled Towards a Constructive AI, a Constructivist AI. And the subtitle is Applying Epistemology Criteria to AI-Based Approaches in Human and Social Sciences. The theme that I am talking about here is the foundation and validity of the knowledge produced by generative AI. And in looking at this theme, I am distinguishing between the application to the natural sciences and to the social sciences. I'll try to make clear what this difference is, and then I will address specifically the application to the social sciences. In this work, we perform an analysis of the affordances of the AI routines in the two areas. Using epistemology criteria commonly used in qualitative research. We conclude from this analysis that AI routines alone are not effective in the social arena. And in order to succeed, they need to work in collaboration with humans. Actually, best if engaging in a constructive perspective, a constructivist perspective. We use this theoretical framework to understand present AI work from the point of view of the theme, the foundation and validity of the knowledge produced. Why am I distinguishing between human and social sciences? In social sciences, there are some facts that are central and are not present in the natural sciences. These are the facts in the conscience of the people involved. In the natural sciences, only real-world facts count. In social sciences, also the meaning that people assign to these real-world facts are central. These sciences explicitly consider the precise and different meanings that humans subjectively assign to real-world facts. Let's make an example so that I can make clear what I'm talking about. Take the work routines in a given organization, a company, a factory. Consider the precise and different meanings that managers subjectively assign to these work routines, to what happens in the factory. For example, a manager can look at his factory as an assembly line factory in which work goes along these lines and workers are called to act one after the other, or just as a platform where reconfigurable work can be planned and organized according to needs. These are two models that exist only in the minds of the people, of course. You cannot recognize these words but just by looking. You can see similarities between the concept behind the words and what you see in the factory. But those are meanings that people assign to what happens in the factory. We are prepared to accept the subjective nature of these meanings. And we are brought then to consider the distinction between these meanings and the underlying reality, which are the work routines, taken as facts of the world. This distinction between real-world facts and the meanings that people assign to them is a very important result of the 20th century philosophy. And recently in our arena of information systems. The work of Claudio Ciborra and Giovan Francesco Lanzara have digged into this. But before them, important names in the phenomenology field, Harold Garfinkel, Gregory Bateson, and Chris Argyris have identified this as a very important theoretical distinction. And this is the base of why applying, studying the foundational value of knowledge produced by computer-based routines like generative AI are different if applied to natural sciences where only the real-world facts exist, or in natural sciences where also the meaning that people assign to them are treated. So let's go back and start the talk as it is. Normally, there are three philosophical approaches that are considered in analyzing the scientific method for qualitative research in human and social sciences. Are the three things that you can imagine and that you know about: empiricism, hermeneutics, and phenomenology. Empiricism is a philosophy based on data. Of course, in social science area, these data are both the real world fact, and which are sensorial data, and the meanings that people have in their mind. That is considered as data. An example of method is the grounded theory method, which exists applied both in natural sciences and in social sciences. Hermeneutics is based on interpretation of data, and phenomenology instead believes in the immediate intuition rather than in rational interpretation. One can think of applying this classification to current AI models. This is an informative exercise. In this work, we reflect on this possibility of the straight extension to AI of the consideration about human qualitative research philosophies and methodologies. Classifying current AI models according to these three epistemological approaches can illuminate their conceptual underpinning and their limitation. This is what we do in this work. We provide hints for directions of future work. We link different AI architecture and styles to the different foundational philosophies and their methods. In doing this, a reference to learning is in order, in particular to the phenomenological hermeneutical learning theory of constructivism. Let's spend some word about constructivist approach to cognition. Constructivism is the phenomenological learning theory of hermeneutics, and phenomenology, as I said, is a learning theory that emphasizes the active role of the learners building their own understanding. Rather than passively receiving information, learners reflect on their experiences, create mental representation, and incorporate new knowledge into their schemas. This promotes deeper understanding. Constructivism is an approach to learning that holds that people actively construct or make their own knowledge, that their reality is determined by the experience of the learner. For example, in elaborating on constructivistic's idea, the scholar Arendt states that constructivist impersonal construction by the learner through experience, and that meaning is influenced by the interaction of prior knowledge and new events. What is in it for AI in this consideration about epistemology? Let's concentrate for a moment in social areas and in the most relevant business areas like accountability or innovation. We can expect that some of this architecture, deep learning algorithms, trained with suitable data harvested in social study or organization, will have to deal with issues requiring hermeneutic abilities that humans use when they do that. For example, cybernetic second-order reasoning, like the assignment of role and responsibility to managers in action, or the consideration of different meanings of work routines, as we said before, in a situation of change. Well, the hermetic abilities are not yet available to AI routines. They may be in the future, but certainly they are not available now. So it is mission impossible without human intervention to expect and ask that these algorithms be able to have hermeneutic abilities capable of distinguishing cybernetic orders or considering different meanings of the same sensual data. What is the way out? Well, long ago, in 1986, two people were claiming that we need a new foundation for design in designing software to run computer application. These are Vinograd and Flores in the famous foundational book, Computers and Cognition. They challenge the traditional rationalistic and philosophical framework that dominates the Western approach to studying computer application. They advocate a shift towards a phenomenological orientation. They said that drawing on the insight of the 20th century philosophers and phenomenologists like Gadamer, Heidegger, Searle, and Maturana. A new foundation for design, they said, with a phenomenological orientation. Let's see what this produces, and then we shall see how we can use their message to get insight into where we should push our effort of using generative AI. We recall the fostering of phenomenological orientation by Vinograd Flores in understanding computers and cognition and retain central concepts. One is a concept in biology, an unconscious biological contribution to human cognition of what they call autopoietic structural coupling of individual biology with the world. This is a work due to Maturana and Varela, who two phenomenological natural scientists who were studying vision in frogs. And they emerged in their study a clear concept. All human beings have the property of producing mechanisms that help them survive into their biology. This mechanism alter the perception of things in a way useful for survival. An example is our pupil that becomes smaller when there is too much light. To widen the spectrum of light intensity we are able to work with in our optical vision. We have produced during evolution this mechanism. There are plenty of similar mechanisms in our being, both sensorial and also psychological. We call them prejudices normally. The fact that we have automatic mechanism that we incorporate through our experiences in our behavior. Okay. This structural coupling between our biology and the external world produces into our biology changes which contribute to cognition in a way which is unconscious to us. This is one important concept that they use in analyzing how we should design computers in a way that I shall describe later. A second concept is the consensus domain, which is generated in human communities by the structural coupling just defined in a situation in which the concepts are shared in a community. So there is a mutual influence of what happens in one individual and another individual in a community. This is important for changing what each individual was learning by the influence from the others. And so there is a consensus domain in producing cognition, both from the unconscious biological contribution and from the rational analysis, as we shall say just now. This shift involves recognizing the following: the importance of action in language. Language is not only an exchange of information, but our communication to the world that are tending to change the world. The role of subjectivity in interpretation. Each individual interpret things in a different way. The significance of immediate intuition in understanding. And the impact of the previously defined autopoietic structural coupling, that is the interaction of individual biological cognition with the external world. The implications of this perspective are far-reaching. First of all, there are two distinct modes of acquiring knowledge, as you have sensed hearing these words. The first is autopoiesis, which is unconscious, and the other one is rational reasoning, which is a conscious process based on mental representation. Let's see. Why is it that doesn't want to? I am sorry, my computer got stuck and I don't know how to unstuck it.
Take it easy, Professor. It's okay.
Let's see. Sharing. It doesn't offer me the opportunity to unshare, because if it did, I would unshare and then do it again. But okay, so what's in it for AI? How our current AI approach is positioned with respect to this shift towards phenomenology? Well, first of all, autopoiesis is a property specific to living organisms, so AI has no access to biological cognition. Second, in rational reasoning, humans deal with issues requiring hermeneutic abilities. Again, to this, AI as yet has no access. For example, AI routines can learn human metaphors just by analyzing human text, and recognizing the metaphors. But they're not able as yet to create new ones, just because of this limitation of not having access to hermeneutic abilities. Then the social dimension of cognition, which operates through a specific consensual domain in human communities, is also inaccessible to AI. I cannot imagine yet different computers producing data from a given data set and then confronting the outcome of other computers and then getting things together. It's not impossible to imagine, but I've not read of things like this. So as for AI, human cognition is mission impossible, at least in the terms as humans do, without human intervention, to be further facilitated by involving community of practice members. Community of practice are those situations in which members practice this communal consensus. So up to here, we have arrived just using the insight produced by Vinograd and Flores in their book, which is 50 years old now. Okay, so let's go a little bit further. Let's consider the philosophical approaches, empiricism, hermeneutics, and phenomenology, in order to see a way out, what we should do once we have understood that we need to create this collaboration between AI routines that lack these two fundamental things, hermeneutics and structural coupling. And let's see where we go. Let's start with empiricism. Positivism assumes that knowledge exists independently of the observer, can be discovered through empirical observation and measurements. AI models based on deep learning largely adhere to this paradigm by looking at statistical correlation from vast amounts of text without understanding the meaning beyond surface level associations. The result is a mechanistic reproduction of language that, while coherent, lacks true comprehension, intentionality, or contextual significance. Let's go to phenomenology and hermeneutics. In phenomenology, by contrast, the philosophy emphasized the lived experience of individual, focusing on how meaning emerges through intentional acts of consensus. Constructivists extend this perspective to positing that knowledge is not passively received, but actively constructed within communities. This perspective highlights the relational, interpretive, and dialogical character of human cognition, aspects that are largely absent in current AI paradigm. So, without incorporating mechanisms that allow for structural coupling and dynamic reciprocal interaction between AI and human agents, large language models are vulnerable to factual hallucination, contextual insensitivity, and the inability to engage in genuine discourse. These are things that were already noted 50 years ago by Vinograd and Flores. So let's imagine application of AI, including structural coupling and consensus, through the collaboration with humans that dialogically interact with the AI program. Bringing this insight together, we argue that contemporary routine must integrate the principle of phenomenology, constructivism, and technical research to move beyond its current limitation. One promising direction is the design of AI system that can engage in dialogical interaction, adopting not just the data they are trained on, but evolving discourse of the communities they serve. This would entail embedding mechanisms that allow AI to recognize, participate in consensus-building processes rather than merely process textual outputs based on statistical likelihood. An illustrative example of this approach can be seen in the different ways people interact presently with ChatGPT. Some users treat it as a simple query response system. Others involve in more elaborate discussions, prompting the AI to refine its responses with iterative exchanges. This interactive potential hints to the possibility of AI as an epistemological rather than a mere retrieval tool. However, for this potential to be fully realized, AI must be equipped with frameworks that take account of contextual dependencies and contribute to knowledge construction in meaningful ways. In fact, there are first indications of a constructive AI. For example, AI as augmented intelligence. The new trend focuses on enhancing human decision-making through the collaborative efforts of humans and AI. Not AI as a replacement for human intelligence, but an harmonious cooperation that amplifies human capabilities without supplanting them. So the learning is not limited to human or to machine, but includes mixed situations. Informed AI is an example where humans provide additional information, allowing the AI to operate with a comprehensive awareness of relevant data, context, and knowledge to make decisions or provide answers with a specific interpretation. It resembles a hermeneutic application. It is based by the choice of human interpretation. So of the two, the interpretation is provided by the humans. And this, of course, inherits the hermeneutic vulnerability, the arbitrary choice of the correct interpretation that the human does, which can be cured by the consensus domain, by using members of a community of practice that have polished their views by sharing them. Further, we are moving towards human-centric explainable architecture, where explainable refers to a system designed to provide insight into how and why they arrived at particular decision output. The goal is to make AI decision-making process transparent, understandable by humans. Again, we are perfectly within the hermeneutic domain. So the must to be followed, this is the conclusion of the talk, is engaging in dialogical interaction with humans towards a constructivist AI. As AI routines are far from affording something like human structural coupling or consensus domain, they cannot access human experience and contextual make meaning and cognition, let alone establishing scientific evidence. We are talking now of the value of the knowledge that they produce. The only path for AI to improve on this front is engaging in dialogical interaction with humans having these affordances. As we have seen, this road has already been undertaken recently. We, with this work, are providing the conceptual framework to support the path of large language models in dialogical interaction with the human towards a constructivist AI. Of course, this human that is being chosen must have expertise in the domain. In force of the reflection presented in this paper, we further advocate for choosing a member of a community of practice in the domain of interest. So we provide the conceptual framework also to support the involvement of a member of community of practice. This is the unique element that can lead to establishment of scientific validity when treating consciousness of people, the data in consciousness, in the conscious. Getting as close in this way to reality with science as it is actually possible in this world. This was my message. Thank you.